back, everyone. My name is Dustin. Sorry, it's been a while since the last engine video. I've been pretty busy with work and the game jam that I was participating in. I've also been trying to get a good handle on the Unreal Engine. And once I have a good handle on that, I'll start making some Unreal videos as well. So look out for that in the future. So in the last video, we were focused on creating the contact listener and getting the user data and object data classes working. And if you haven't seen that video, you can check that out right here. This video will be a direct continuation of that video, okay? So in this video, we're going to create the contact listener bindings, and we're also going to quickly go over a Lua event manager. We'll eventually move the event manager to a C++ class. However, this is just to demonstrate that the engine as is can handle a lot more than we give it credit. All you have to do is create the necessary systems and classes that you're needing and just do that in Lua. And everything you need is already provided. Right here, we're just looking at the current GitHub repository from my GitHub manager here. And these are a lot of the changes I made in the background. So I actually asked you guys to, as a little challenge, to create the toString function right here for all the components. So I went along and did that for each component. And I also added a few things. I added this all components where we just add each component there and we just include this and we end up with all of the components. I also added this core utilities file here. So all this is, it has the RST model. So this is the rotate, scale, translate. So that's what that'll do. So instead of having that code, all that code that's the same, we just put it into one. And this one is the entity in view. So it's for calling out the entity. And we'll go over that later, but this is going to be pushed with this video once this video is completed. Also with the asset manager, I also added in the adding shaders from memory. I added that in, and the animation system changed a few changes we're in here, see here with the entity in view, right? So that's why I did that. I did the same for the render system and the render shape system, all that stuff. Okay, so all this has been removed and put into one function because it's used in multiple places, okay? And then the shader loader, so see the shader loader, I had to add a few different things so we can do this from memory rather than always reading it from a file, because we'll have some shaders that will just be part of the engine. So they'll just be natural shaders. I just did the toString for the vertex for the color, made some changes to the wrappers. So we're now just using the Scion log instead of std.cout. Added some new keys in there and made some small changes to the window and stuff like that. So if you open up your Scion2D, as you can see here, all my Box2D stuff is in red. It's because I changed how I use Box2D for the engine. So I changed it to use the x64 Windows static. So we're going to have to go do that now. So what you need to do is open up the command prompt and move to your, wherever you stored your VC package. And then we're going to have to put in this command here. If you already have it installed like this, so VC package, remove Box2D x64 Windows. Now I've already done this. You can see this has already been in. It sees that we have the x64 Windows static. I don't need to remove that because that's what the one I want. So if once you have that removed, we actually want to install the static. So what you do is you take this command here, VC package install Box2D, and the triplet will be x64 Windows static, okay? I've already done this, but I'll do it again. See, it's already installed, and it tells you the version that we have installed, okay? Perfect. So now that we have that installed, you wanna go to your VC package, and you wanna go to the install, and you wanna go to Windows static, and we're gonna need to grab the Box2D includes, okay? So we're gonna need all this stuff here. So we'll just copy this Box2D include, and then we'll open up another file explorer. And this time we will go to our, wherever you're keeping your Scion2D, and we'll go to our dependencies, and we need to add in Box2D. So new folder, Box2D. And inside of here, we're going to need to add an include, and then we're also going to want to add one in for libs. So lib. And let's go in here and just paste in that Box2D include with all the header files. Cool. And then go back to the libs. And inside of the lib, we're going to have two different ones here. So we're going to have a debug. And we're going to have a release as well. And we're going to have to make sure that we link these correctly in our project. So we'll get to that. Okay. So now that we have those, let's go to this one here. And we need to go back and go into our libs. And this one is the release lib. So we need to grab Box2D, copy that, go to your release, paste it in there, then go back one, go to debug, lib, and we want to grab the Box2D lib, and go back one, go to the debug and paste it there. Cool. So once you have that in your dependencies from your VC package or however you installed it, well, we need x64 Windows static. So it needs to be a static library. And we're going to have to make some changes. So let's go back into our project. And the first thing we want to do is actually go to our core. And in our core, we need to add in all of our VC directories and library paths. Go here. Go to our dependencies. Box2D, include. This needs to be a solution dir. We've done this before, so it's all the same. Okay, add that in there. Oh, this should actually be for all configurations for this. So we'll just say no, so we won't save it. We'll just do this for all configuration here. Okay. Go to your dependencies, Box2D, include. Paste in that. We had that in my cache or my clipboard. And these are going to be different, so we'll leave that. So let's apply this. Go to our librarian. Down here, we're going to need to go Box2D dot lib. Okay, apply. All right, so we have that. And then now we got to go back to here, and then we need to adjust for debug. We're going to want the debug lib. So here, dependencies, Box2D lib, debug. And change this to release. Do the same thing. For release. Cool. All right, so that one's good. We have to do the same thing to the editor and to the physics. So might as well do physics first. Go to the properties, change this to all configurations. And we're going to want to include. Okay. Go to our librarian. Box2D.lib. Cool. Go back to our VC package, change this to debug. Yes, let's save it. Libraries. Lib, debug. Go to release. Do the same thing. And let's do it to the editor as well. So go to the editor, properties. So all the same stuff we just did, I'm going to quickly just go through it. Okay, so I think that's everything. So let's actually just go to debug first and try to build. Okay, so it looks like we have some errors. If we go to our errors, and it's showing this here that we have a mismatch detected for the runtime library. This is an MTD, and we are using an MDD. So the difference here is the MTD. Actually, let's just open it up in the Microsoft. So here, so MD, so it's using a multi-threaded with DLL specific version of the runtime library. And the one that we're using now needs to use the static version of the runtime library. So it's expecting all the projects to have the same runtime library, okay? So we need to make that change. So here, since we're in debug, so let's go through all our projects, okay? So we'll even start with the GLAD. We'll just open this, go to properties, go to our C++ code generation. Right here in runtime library, see it's MDD. So we'll actually just go to debug first. Let's change this to MTD, apply. Go to the next project, MTD. Okay, so that's for debug, and let's do release. And release will just have the MT, and do it for all the projects. Okay, and let's do a rebuild. Alright, so debug is slow as slow can be, but it's working. Let's just now rebuild it in release just so we make sure that they're both working. So it's going to take a bit. See you soon. Alright, so release build is working. That's great. So now the goal for today is to get our contact listener actually working and sending us some data back right here. So when we go in and we hit that, we get some data coming back. That's the goal for today. Okay. All right. So let's close it down. All right. So the first thing we're going to want to do now is actually start our contact listener binding. So if we go here to our core and let's go into our scripting, add new. And this is going to be the contact listener bind.h. First thing we want to do is get soul. Then we want to get the contact listener. That's in our physics contact listener. And then let's get ENTT as well. And then let's go namespace, Scion core, scripting, class, contact listener binder. And we'll have a private, and the private and public. And we're going to have a static std tuple. And these are going to return two soul objects. Soul object, soul object. And the objects that we're passing back is the user data. So get user data, and that's going to return the two contacts that are touching at that moment. Okay, this can send back multiple types, and we'll get into that later. So then we use Scion physics, not core. Scion physics, contact listener, reference, contact listener, and then this state. So soul, this state. Cool. Now we're going to have one function here, and it's going to be static void create Lua contact listen soul state and the registry. Cool. Let's create these. Okay, so let's quickly fix this. It's looking a bit verbose. So name, space, Scion for scripting. Grab all this, place that in there. Get rid of that. Get rid of that. So we're going to need a few things. We're going to need our meta. So ECS, meta utilities. Then we're going to need our user data. That's in our physics user data. And we might look at our logger. Using namespace. Cool. So the first thing we want to do is get both of the user data pointers from the contact listener. So we can go auto p user data a, equal to contact listener, get user data a, copy this, user data b. Cool. Now we want to check to see if they're both null pointer or not. And if either are null pointer, we're just going to return a tuple with two Lua nil objects, okay? We only care if we have both the contacts user data, because if there's not, we don't care. Okay, so if not p user data a or not p user data b, now we're just going to return a std make tuple sol lua nil t object sol lua nil t object. Okay. Otherwise, we continue. Now for the fun part, since we have both the user data, we're just going to add in a quick assert here. So let's say Scion assert. This will only work in debug, but we say p user data a, type ID is not equal to 0, and p user data b, type ID is not equal to 0. We don't want that to have no user data type. So we say user data type ID must be set. Cool. So otherwise, we need to go using namespace DNTT literals. Now here we want to use the get user data meta function that we created earlier to get the underlying data for both the return contacts. So we want to go const auto maybe any a is equal to invoke meta function. And here we're going to say static cat, and we want to go ENTT ID type of our P user data A type ID. Okay. And then from here we want to say get user data HS, and we want to send in the dereference P user data. Okay. Because this one is sending in a reference, and we want to send in the sol state as well. Okay, so we can copy that and do the same thing for B. B. Cool. Scroll this down a bit, make this a bit bigger. So now here we want to ensure that both are valid. If not, return nil objects again. We only care if both of the contacts data is valid. Okay, so we're going to say if not. Actually, we can just copy the whole thing up here. Copy this and place this here and just change this to the maybe A, maybe B. Cool. All right, if we've made it this far, that means we have both the contact information and we can set them to their type and return the tuple. So we can go return std make tuple, and we want to say maybe any A cast to the sol reference. And we want to do the same thing for B. Now we don't have to worry because we know that if it made it here, they're both good. Okay. All right. And that should be it for this function. So that's our get user data function. Beautiful. All right, and now for the contact listener binding. So inside here, so we don't want to create a new contact listener. We want to leave the creation of the contact listener to the engine. We don't want the user to have to create it. It should automatically be created as soon as they enable physics, okay? So therefore, we'll have to get the contact listener from the registry context, okay? So we go auto reference contact listener is equal to registry dot ctx dot get std shared pointer of the Scion physics contact listener. Then if not contact listener, on stack. Due to some error here, so we can just say Scion error failed to create the contact listener Lua contact listener listen is not in the registry. Oh, and just like every type, we just create a new Lua user type. Okay, Lua.new user type. Scion physics contact listener. I'll just say contact listener. So no constructor. The only function that we care about right now is the get user data. So to get user data. So this state, and then this return get user. I gotta send in the contact listener. And the state. Awesome. Awesome, that should work. Okay, so let's just got that semicolon there. All we have to do now is add this to the Lua binding in the scripting system. Then we have to make sure that we are adding the contact listener to the registry, okay? But we also have to set our contact listener in the physics world so the physics world knows how it needs to update the contact information. So let's do that now. Okay, so let's go to our scripting system. Systems, scripting system, up here, go to the top. And our scripting, add in our contact listener vine. Go to scripting here. And then we want to say contact listener binder, create contact listener. This takes to take in the registry. Registry dot get registry. All right. So now we need to go to our application in the editor, source, application, and make sure that we added in the contact listener. So where's our physics stuff? Are we adding anything physics yet? Doesn't look like it. Right here, nope, physics system. So we'll just add it right here at the bottom. So include physics contact listener. And then wherever we do our physics system, right here, the physics world, cool. We will create our contact listener. So go auto p contact listener is equal to std make here Scion physics contact listener. And then we want to say if not mp registry context. Actually, let's just copy this whole thing here. Sorry. Paste that in. And we need to change this to the contact listener, shared pointer of the contact listener. Paste, change this to the contact listener. Oh, failed to add the contact listener to the registry. And now we want to add it to our physics system. So we need to go, not the physics system, sorry, the physics world right here, the physics world. We need to go p physics world dot set contact listener. And we need to set it to our contact listener. So p contact listener. Yeah. Cool. All right, so let's quickly build this to make sure it works. All right, so that worked. So now we have our contact listener, and it's doing its job, but we need to make sure that it's doing its job. So let's close this and open up our main.lua. So in our editor, wherever our scripts are, main.lua. So we got all this going on. And we can come down here. So this is our keyboard, some keyboard testing I was doing. We can get rid of that. And for now, let's go. So it's returning a tuple, so we're getting two things back, user data A and user data B, right? So we got to go local UDA UDB is equal to contact listener dot get user data. Then we're going to go if UDA and UDB, then let's say print user A UDA to string. I believe we made a to string function for that. Copy this UDB to string and end. Okay, let's see what we get back. Okay, so as you can see here, we're not getting much back here. Let's see if we get anything else. Not getting anything back. No data at all. Well, we're getting data back, but no, there's nothing in the name, so nothing must be set. Okay. So nothing's touching, so it shouldn't be getting anything back, or we're not getting anything back here. So we gotta fix that. And that's because we never set the player object data. If we go back to our physics component, go to the bottom, we have now an object data that needs to be filled out for the player. Okay, so let's go to our main.lua. And here we need to go player physics attributes dot object data is equal to, so the player object data, so we go object data player no group. Let's say true for a collider, false for a trigger, and then we need the player ID. So D player ID. Okay. Let's just run that real fast, see if we at least get the player IDs stuff back. Yeah, see right here. So we have our player ID. So all that's coming back, but we're not getting any data coming from the colliders that we're touching. We need that data back. So that's showing that our contact listener is working. As soon as we touch, see we got our player, that data's coming, that information is coming back to us. Let's close this. And we need to go into our utilities.lua right here where we're loading in our tile map. And up here, because we're doing the triggers, yeah, so if collider or trigger in here. So if it's a trigger, right now we're just going to give it a hole trigger. So we can just say, like we'll call it a hole, like a hole in the ground. Okay, so we'll just say object data is equal to a new object data, no tag, but we will give this a group and it'll just be hole, hole triggers. Cool. False, true, yes, it's a trigger, not a collider, and the entity ID. I believe we were using an entity here. Oh, tile. Tile ID. Cool. Else, we need to put an else here. we'll just call this colliders. Colliders, true, false, because it's not a trigger. All right, let's run that and see if that does what we want. So let's just make this a bit bigger. Yeah, so you see we're on a collider and it's giving us all the information for the colliders that we're on. See how the ID is changing? Because we're on different colliders. So if we jump up here, but then if we fall down here, oh, see the whole trigger? So now what we need to do is have an event manager where like full triggers trigger an event. Okay, so let's get into that. We're gonna have to do that in Lua, okay? Oh, we close this, close this. The first thing we want to create now is the event manager. Now this is all going to be done in Lua. Eventually we're going to move this to the C++ side and we're going to have the ability to talk to Lua with the event manager. But we'll get to that later on. It's not as important right now. But right now we do need to add in an event manager. So let's actually just add in new folder in our scripts and we'll call it events. Okay. And in the events, we'll create a new item and this is just going to be the event manager.lua. Cool. Okay, so right now we're going to create a little wrapper function that will create new classes for us. And it will basically, it will be a function. It'll take in your object that you want to create, and then it'll also take in the params in that object for what we want to be the parameters for the particular object, okay? So we'll say function create object, and it's going to take in the object type that we want to create. Okay? And then here we'll have a new function that is an object that sends back a new, but it also has the parameters of this object, of this. So n. Okay? And inside of here, we're going to say this, we've done the classes before, is equal to params or an empty table. So if there's no params sent in, it's just an empty table. Now we're just going to do the set meta table, and it's going to be this and self. Then we want to go self dot index is equal to self. Then we want to return this. Okay, so we're returning this with the parameters based on this object. Okay, and then we want to return the object. Return the object. Okay. So now that here we need to define what a subscriber is. You're going to have events that will emit events and then subscribers that will subscribe to the event that it'll be listening to, okay? So we need to say subscriber is equal to a new table or a subscriber namespace. And we're going to say function, and we want to go subscriber create. So we're creating a new subscriber, okay? And it's going to have a function. And it's going to say self update, and it's going to take in some param, function n, and we'll return the create object, taking in the subscriber and calling the new. This one's not going to take any param for this new. Subscriber doesn't have nothing. Then we're also going to have an event. So let's say event is equal to table, function, event, create, self.m subscribers. That's just going to be an empty table for now. And it's going to have a couple functions. We're going to have function self.subscribe to event. That's going to take in a subscriber. And so then all we want to go is table.insert self.m subscribers and add in the new subscriber. Then we're going to have another function that is just to unsubscribe. So we could probably just copy this here, change this to unsubscribe. And then we want to send in the subscriber that we want to unsubscribe. And here, we're just going to go for KV in pairs. Self.m subscribers. So we want to loop through all the subscribers and check to see if V is equal to this sent in subscriber. Then we want to remove it. So table dot remove self.m subscribers at K. And cool. And another function is going to be function self execute and then return create object event. Okay, so the reason we're doing it this way is because we need to use it for inheritance. None of these will be filled out by the object that we're creating. Okay, does that make sense? So all these functions will be part of the events that we create later. Then we can also have down here function event reset subscribers. And this will just clear everything. So for K, V, and I pairs. So M subscribers do. So M subscribers at K is equal to nil. And end that. Cool. And end here. All right, I think we have everything we need. So basically, this is just going to use inheritance. We're going to create subscribers, and we're going to create events, okay? So the first event we're going to create is actually going to be the collision event. So let's do that now. Here, in events, new. And it's just going to be collision event.h. Sorry, And the collision event is pretty straightforward. We want to create a new event based on the event class, and that's going to be the collision event. So collision event is equal to event.create. Okay. So this will also have its own functions where we say function collision event create. And we'll say local object A. And we'll just have these start out as nil, local object B is equal to nil. And we'll say function self execute. And we're going to loop through all the subscribers for the collision event and call the onCollision function for that subscriber. So that means each subscriber needs to have the onCollision function. Okay. So we need to go for K V in pairs of self.n subscribers. Now, how does it get the m subscribers if we didn't declare here? That's because this is using inheritance. It's using Lua inheritance where it is an event. This here is an event, okay? So we're creating an event and it has everything that an event has. Changing the collision event to have its own functionality, okay? So here we have the event and it has an execute. This is basically an override of the event execute here, right? So it has an execute, and that's why it was left empty. The same with subscribers for update. This is left empty because it's going to be overridden by the new subscriber that we create. And our subscribers will actually be system, okay? And we'll get to that. So here, anyone that subscribes to a collision event needs to have an onCollision function. So we need to go v onCollision, and it's going to take in our object A and object, of course, object B. Okay, and that's it. So it takes in this for the onCollision function, and then we need to be able to emit an event. And the emit event is what will set our object A and object B. Okay, so here we'll say function self emit event. And it'll be let's go obj A, obj B, just so we can differentiate between the other two. And all we want to do now is go object A is equal to object A, and then object B is equal to object B. Cool. And then we want to call the execute function above, all right? Because now we'll have our object A and object B. We can call the on collision function of the subscriber, okay, on the two objects that were sent in. Execute right there. All right. And then here we want to return create object of a new collision event. It's its own thing like that. So basically this is creating its own type based off this type. All right, cool. We're almost done. So now that we have our collision event, we can create our system, okay? And it will be a trigger system. So here we'll create another new folder, add folder, and this folder will be systems. This is Lewis systems, okay? And from here we go add new, and we'll call this a trigger system.lua. Trigger system.lua. All right. And the trigger system is going to be a subscriber. Okay. So it's inheriting from the subscriber class, the subscriber Lua class, and then we're going to add its own functionality, right? So we go trigger system. We need to go function, trigger system, create. So basically right here, all we're going to do is create the new class, the new triggered object. So create object, trigger system, and we're going to return that, okay? And then we want to say function, trigger system, on collision. Because this is a subscriber, it needs to have the on collision. Not all subscribers need the on collision, just the ones that are going to be part of the subscribers for the collision event. And our trigger system is going to be subscribed to the collision events. Okay, so on collision, it needs to take in object A and object B. And then from there, we can just add whatever we need in here, okay? Because we're adding in our object A and object B. So down here, I'm going to create another one for if player triggers. So function. Oh man, I'm off. Function, trigger system, on player triggered. And it's going to take in the trigger, and it's going to take in the player. Okay, so what trigger and the player. And then here we're just going to say, because we're actually getting object data here, right? So let's just print the trigger group. So let's say trigger dot get group, and then we can say trigger dot get group has been activated by player.getTag. Okay, and then we can do some other stuff here if we like. We'll worry about that in a minute. But the first thing is we need to be able to call this, and we'll do this in here. So we go if object A dot. Let's go quickly back to how we set up our object data. So let's go here. Where's our object data bind or Lua data bind? That's in our physics component, I believe. So let's go to our physics component. Physics component, object data, that's our attribute. So here, in our object data. So yeah, it looks like that's something we forgot to do here. So here, we need to be able to get our tag. And you know what, we're not going to do get tag, we're just going to say tag and send back the object data tag. Object data, object data tag, then this is group, then this will be B collider, B trigger, and entity ID. So we'll change this and we'll say entity ID, B trigger, B collider, and the group. Cool. So if we go back to our trigger system here, it's not going to be get group anymore. It's just going to be dot group. And it's not going to be get tag. It's going to be dot tag. Dot tag. Then if we up here, if object A is a trigger and object B dot tag is equal to player, then we want to call self on player triggered. Then we want to send in object A and object B. And so we can copy this, paste that here, and just change this. If B is the trigger and A is the player, send in B as the trigger and A as the player. Okay, cool. We're almost done that. So now all we have to do is go and create these. Okay, so let's go back into our main.lua. And where's a good place to put these? So we're going to need to run these scripts. So we're going to need to go, let's just copy a new line here. Assets, scripts. Where are these? Assets, scripts, events. Events slash event manager.lua. We need to run these scripts, right? And we need to do the collision event. Then we need to do the trigger system. Cool. All right, and once we have those, let's create our events. So we need to go G, collision event is equal to a new collision event, create. Then we can say G trigger system is equal to trigger system, create. Then we need to now subscribe to the collision event. So we go G collision event dot subscribe to the event and send in G trigger system. All right, so now the trigger system is subscribing to the collision events. Okay, so now that we have that, if we go down here and instead of sending this data here, we can get rid of this or just comment it out for now. We can go G collision event, emit event, and we can send in our UDA, UDB. It's not really user data, it's object data, but it's object data, user data, pointer, blah, 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 blah. So now we should actually be going into the trigger system, and when we touch our triggers, it will tell us which one did what. Let's see if that works. Okay, so we got some errors here. Most likely, I was trying to fly through that. And it says right here, yeah, because I put it in events, it's correct. So here, let's go back to main.lua. I actually had this in systems. So trigger system is in system. Let's try to run that again. Awesome. So now if we fall and we touch the green, oh, look at that. Awesome. Now our trigger events are working. Our collision system is working. Look at that. Both triggers have been. But that's fine. So that's doing exactly what I wanted to get done for this video. Okay, so now that we have that working, it's doing exactly what we want. Now I do have some problems. When I was doing the jam, I found a couple issues, and one of the issues was this here. If you're touching multiple things at the same time, like wall, trigger, 2 triggers at the same time, it's not going to give us those back. It's only going to give us one thing. You know what I mean? So we need to have a way for the object or the player to hold on to everything that it's touching. And as it exits and is not touching that, we need to remove it. Okay? So that's a little challenge for you. Take a little think, see if you can figure this out. You need to be able to, so say we're in a corner and there's 2 things here. There's an enemy here and a trigger here. Well, that's going to be 2 things, but the way that we have it right now, if we go to our collision, let's go to our physics here. Physics, contact listener, right? It's setting it to null pointers on the end contact. So you're only really ever going to get 1 at a time. And it's going to be random. It's whichever one it gets in order, right? So you're setting all we're doing is setting our user contacts here, and we're setting it here, our information, right? Let's also go back to here, to our scripting. And I think it is in here. Yeah, this is just setting, blah, blah, blah. Ignore that. Yeah, so here, we're only going to get 1 thing coming back. So we need to make a change in order to get multiple things. So if we go to our object data, that's where we need to make the change, is in our object data. So physics, user data. What can we do in here that will allow us to hold on to multiple things? Okay, I'm not going to give it away. It's a little challenge for you. We need to be able to hold on to multiple objects of different entity IDs that we're touching. Like, what are we touching right now? And also, as we come off of it, as we end the contact with that object, we need to remove it from our holder or our container of objects. Okay, so give it a try, see what you can come up with. I'll try to put a better idea of what we should do in the description and see if you can if you can figure it out. If not, hopefully that's all working for you. And this shows you that you can right now, as is, you can just make different systems in Lua. You don't even have to do the C++ side. Like, we created the event manager and we did all these. We got the trigger events, and you can actually move the player if you like. That's another little challenge. So right here in our trigger system, yeah, right here, try to have it to see what the group is, right? And call another function that will adjust the transform of the player. So when we play it, if you hit the hole, have it trigger. So if you hit here, if you hit this here, have it so you die and you start back here. So even if you come over to this one here, have it so, oh, your player died and he goes back to the beginning. So that's your goal for that one. So that's a challenge that you guys can try out. Okay. All right, let's close this. Okay, so that's it for this video. If you have any questions, let me know. Please like and subscribe. And in the next video, we'll go over both of the challenges. Okay. All right, that's it. Take it easy.